Hi, good day. I hope you're having a good day. We're going to talk today about what happens when light travels from water into air and the angle of incidence is greater than the critical angle. Well, let's just talk about the transfer in particular in order to understand what the critical angle means. Energy transferring from the radiation transferring from the higher index of refraction to a lower index of refraction material, as water and air are, allows us to use this relationship, n2 times sine of theta 2 equals n1 sine of theta 1, when determining the directions that the air angle will have when the water angle is a certain amount. The critical angle is defined as the particular angle, theta 2, that makes theta 1 equal to 90 degrees. In other words, that makes the energy run along the surface and not actually be able to get out of the surface. And so the thing that occurs at the critical angle is a total reflectance. We can set it up in this way. I've got a pool of water, and in the pool I have a rock. The sunlight comes down and hits the rock and scatters in lots of different directions because the rock is not smooth, it's not a mirror. So the angle that we look at, well, let's try looking straight above. The ray impinges perpendicular to the surface and is emitted perpendicular to the surface to the eye. And the angles that we're going to measure, angle 2 is 0 and angle 1 is 0. Those are the two angles here. This has to do with the calculating the odd angles equal to the sine of the -1 of n2 over n1 times the sine of the even angles, which we provide here in this diagram. Theta 4 is 30 degrees, and you'll see that then theta 3 moves up here at 41 degrees from the perpendicular. Theta 5, impinging at 45 degrees, ends up at 80 degrees. And then we try to do 60, and we have a little problem because the sine of the -1 of 1 point of anything above the angle of 90 degrees ends up giving us an error. And in fact, what happens is the ray impinging on the surface totally reflects at the same angle as the reflectance rules, which in this case would be at 60 degrees. But it's actually 60 degrees back into the water. The critical angle is defined as theta 2 when theta 1 is equal to 90 degrees. And we see here that using the same relationship as we used before, the sine of theta 1 is the sine of 90 degrees, which is 1, which is equal to 1 over 31.33, which is 48.75 degrees. The energy that we are transferring from the lower surface to the upper surface is actually higher in percentage transferred at the lower angles and lower in percentage transferred at the higher angles. And the percentage goes to 0 at the critical angle.